Okay. Hi, everyone. Thanks for coming. I'm really glad and excited that it's so many of you in here, in the basement. So, my name is Grzegorz Dyrda. I'm a software engineer for about 15 years, I guess. I also run my own company called Geeky Devs, in which I make mostly Android apps. And today, we're going to talk about one of the best things, at least in my opinion, one of the best things that happened in the JVM world recently, which is Kotlin. So let's start right away. What is Kotlin? Kotlin is a statically typed language for the JVM, Android, browser, and native. Browser because, like you all know, every modern language has to compile to JavaScript. Native because Kotlin also works with the LLVM compiler. So you can already compile your Kotlin code against Windows, Linux, macOS, and iOS, for example. It's been developed since 2010 by the JetBrains, so the people behind our beloved IntelliJ IDEA, for example. Kotlin is also similar to Java in many concepts. It's just free of all of its legacy problems and issues that we all know about. However, Kotlin can be mixed with Java in one project without any problems, and it compiles even down to Java 6 bytecode. So we can freely mix Kotlin with even our legacy projects, for example, your legacy Spring projects. Also, Kotlin doesn't introduce any specific build system. It simply works with all the tools that we already use, like Maven, Gradle, or even Ant. Also, Java libraries work without problem with Kotlin. And some of the benefits that surface very early on are, I think first, it's improved code safety or reliability. I'm sure you've already heard about how Kotlin treats its null values. So our code is much safer in this case, in this regards. Also, the code is much more concise and readable, and also Kotlin contains really many of the features that all other languages have, but Java doesn't have and probably never will. And last but not least, Kotlin is actually really easy to learn, because it's similar to other languages that we use on a day-by-day basis, like C# or JavaScript or Apple's Swift, for example. So let's talk about those features. What Kotlin actually gives us. So first, it's this null-safety. So if you've ever heard anything about Kotlin, it was probably about the way it handles null values. So the way it works is that you, as a developer, you can decide whether your reference can be set to null or not. If you decide that it can't be null, then your code is safe. Nobody will be able to put a null value in this variable. But if your business logic, for some reason, requires this null to be a proper value, then you can allow it, but this implicates that you, as a developer, you are obligated to properly handle this null value, because otherwise, your code even won't compile at all. Second thing, Kotlin doesn't have checked exceptions. I'm sure you know that Java was the first and also the last language which introduced checked exceptions. So Kotlin, of course, has exception handling, but all exceptions are unchecked. Also, another great feature of Kotlin is extension functions. So it's a way of adding new functionality to the existing types that you don't control. So for example, you can add a new method to the string type, even though the string is final. And moreover, this doesn't break any binary compatibility or whatsoever. You will see this in a couple of slides on the examples. Also, we have higher order functions. So a function can be an argument to another function. A function can be returned from a function. We also have proper function types and lambdas, so no more hassle with some interfaces, for example. We also have default argument values and named arguments, like in Python, for example. There's also class properties, which are a simple short syntax for private fields and public getters and setters. There's also a thing called type inference. So in many cases, you don't have to write a variable type or a return type of a function explicitly, because it will be inferred by the compiler. There's also operator overloading, but don't worry, there's no way to add new operators like in Scala. There's only a way of overloading the existing fixed set of operators. And we also have coroutines. So if you ever heard about async await from C# or generators yield from Python or even channels from Go, they are all here and even more. And there's much more. There's much, much more. Of course, we won't cover all of them during this talk. What's important for us is that Kotlin is a kind of a toolbox for us, where you have a proper tool for every possible scenario. You just need to reach and grab it when you need it. And imagine that you have all of this, plus a seamless cooperation with Java in one project. Plus, it compiles even down to Java 6 bytecode, so you can easily introduce Kotlin into your projects file by file, class by class, even into your very old legacy projects. Plus, it has syntax which is similar to other languages that we use. Plus, it has great tooling because of JetBrains. Plus, it has great community, especially on Slack. And plus, it's still under rapid development, so Kotlin gets even more and more features over the time. So, okay, enough of the theory. Let's see how this actually looks like. So, a simple function or method in Java, the same function in Kotlin. Here we have a fun keyword, fun like function. The name goes first, and then the type of the argument, and the return type of a function goes always at the end. Semicolons are optional, but we usually don't write them. But here we can already leverage one of Kotlin features, which is if we have a single expression function like this one, we can simplify it by removing this return and those curly brackets. And also, we all know that that both A and B are integers, so their sum will also be an integer, so we don't have to write this explicitly. And this is type inference in action. When it comes to function arguments, a simple function that repeats a string number of times. The same function in Kotlin. But we can make this one better. First, let's introduce default argument values. So this way, we won't have to make 3 separate overloads with 1, 2, and 3 arguments. But still, if we look at the call side, we actually don't know what this 5 does, really. In Java, we are kind of used to functions like, or methods like showWindow, which takes true, false, 2 empty strings, and another 2 booleans. And we don't really know what they do, or what they are actually, until we look into the documentation, right? So in modern languages, we don't have to do this. We can take advantage of named arguments. So basically, we can use the same argument names which were used during function definition. And then we can, of course, use the first one, or both, or only the second one. When it comes to variables, 2 simple variables in Java, the same variables in Kotlin. Here we have another new keyword, val, like value. There's also another one, var, like variable, which will be explained on the next slide. And again, the name goes first, and then the type. And we know that 1 is an integer, and XYZ is a string. So we don't have to write this explicitly. This can be inferred by the compiler. As I said, we can choose from 2 different keywords when creating a variable. Val, or value, is basically like a final variable in Java. So we cannot reassign its initial value. While variable is just a plain old variable when we can reassign its value at any time. And it's always a good idea to start with values and change to variables only when necessary, because it clearly shows our intention. Okay, so let's talk about this famous null-safety. Very simple example. We have a string variable, and we try to set it to null. Will this code work? Will it compile? How do you think? Well, it won't. Why? Because Kotlin has one simple rule. All of its types are non-nullable by default, so we cannot set them to null. But if our business logic requires this null to be a proper value, we can allow it by adding a question mark after the type. But now, we are obligated to properly handle this null value, because otherwise this code will not compile. So let's see it on another example. We have some simple function that takes a string and returns its length. Question, will this code compile? Yeah. Yes, it will. Because this string in the argument is a non-nullable string, so we can safely access all of its members. But how about now? Now we have a nullable string in the argument. I'm sure you already know this won't compile, because in case of null, we would get a null pointer exception during runtime. So Kotlin compiler cannot allow us doing this. So what can we do with it? First, a good old null check. And you can already see how smart casts work, because the compiler already knows that the string will never be null inside of this if block, because you already checked it. But we can make it better. We can take advantage of a safe access operator. If you know Groovy, for example, it's taken from Groovy, I think. The way it works is if its left side, which is our string, if it's not null, then it evaluates the right side and returns a result. But if this left side is null, then it skips the right side altogether and simply returns null. So it basically swallows potential null pointer exception in favor of returning a null. There's also another operator called Elvis operator, for obvious reasons. And the way this one works is if its left side is not null, then it evaluates and returns a value. But if the left side is null, then it simply returns the default value, which is provided on the right side, which is 0 in our case. And of course, in real-world projects, the situation is always much more complicated, like this one. User has address, and address has a zip code. So what's the standard way of doing this in Java? Well, either nested if blocks, like here, or maybe some try-catch. I'm not sure which one is worse. In Kotlin, we can simply chain those operators. And if any of those subsequent values is null, we will simply return null instead. And of course, we can simplify it a bit. Okay, string interpolation. Small thing, but very handy. So instead of writing code like this, we can do it like this. So basically, we can embed symbols inside of strings if we put a $sign before them. And we can simplify it. Kotlin also has parts of pattern matching. So it's not full pattern matching like in Scala, for example, but at least we have some elements. So when is basically like a switch on steroids. So here we check if x has some certain value, or if it fits into some range or maybe a collection, or if it has some certain type. And you can also see how smart casts work in here, because in case of type checking, you can see that this x doesn't have to be explicitly cast to the proper type. If it's long, it's already treated as long. Or if it's a string, it's already treated as a string. We don't have to do it explicitly. Okay, let's talk about classes. A simple user class in Java with 3 fields, a constructor, and a crash. Yep. A simple user class with 3 fields, a constructor. Fields should be private, and they should have public getters and setters. And if we want to use it inside of, I know it's not easy to read and it's intentional. If we want to use it inside of any collection, we have to also override hash code and equals, and maybe put toString to make debugging easier, right? This gives us over 50 lines of code. And of course, we know we can deal with this by using some kind of tool like Lombok or AutoValue, right? But let's make an exercise. Let's select all of this code, press Ctrl-C, open an empty Kotlin file, and press Ctrl-V. We would see a kind of dialogue. IntelliJ basically says, hey, I discovered a Java code. Would you like to convert it to Kotlin? Of course. It's better, but it's definitely not perfect. Who can say what's missing in here? What's no longer in here? Setters and getters, right. Why? Because these are not fields. These are properties. So the short syntax for private fields and public getters and setters. And because our getters and setters didn't do anything special apart from setting and obtaining its values, we don't have to write them explicitly. Next, toString. We already know about string interpolation and single expression functions, right? So we can simplify it to look like this. Next, this for Kotlin looks very complicated because each variable name, like the first name, occurs like 4 times in here. What can we do with it? Well, we can take advantage of a thing called a primary constructor. We put it right after the class name, and the interesting thing is that all of its arguments automatically become the properties of this class. And now we're left only with a couple of very standard methods. I'm sure you know that almost every modern language has a way of dealing with those. Kotlin also has its own way, and it's called a data class. Data basically gives us hash code equals to string and a couple of more. For example, copy, which is basically a clone on steroids. And because we can put multiple items in one file, in Kotlin, we can do things like this. We can, for example, make a single file with all our database models. Okay, let's talk about singletons. This should be easy, right? So, what's the proper way of making a thread-safe singleton in Java? Is it like this, with public static field? Or maybe like this, with a getInstance method? Or maybe like this, which is synchronized and even more lazy? Or maybe like this, by using an enum? I'm sure you get the point. Simple things should be simple, so why is it that complicated? Let's see how can we make a singleton in Kotlin. How can we make this class being a singleton? Try not to blink, because this is a quick one. Done. Kotlin has the concept of objects, which is taken from Scala, probably. Objects are basically singletons, so you no longer have to worry about the proper implementation of your singleton, because you are simply provided with the one and only proper implementation. Okay, so let's talk about those class properties. When we define a property, we can use the same 2 keywords, which we used during variable definition. If we use var, our property will be mutable, so it would have getter and setter. But if we use val, our property will be read-only, so it will only have a getter. How do we use them? Well, just as if they were public fields. But under the hood, the proper getter or setter gets called. So let's see how can we actually override those getters and setters. How can we make a custom getter? For example, like this. And of course, we can simplify it a bit. And this is how we can make a custom setter. And this field in here, which is in bold, this is actually this private field, which is accessible only from within its getter or setter. Okay, Kotlin also has the concept of top-level functions, which are functions that are defined not in any class. They are defined at the top level of the file, like this, for example. And we use them just as if they were a kind of global functions. So they are basically a cure for Java's import static. We all know how import static works, right? First we create a class, then we put a static method in it, and then we pretend that this class doesn't exist. But it's a lie. So this is just an easier, more straightforward way of doing the same thing. And actually, a couple of the functions that we already use in this example, like the print one, it's an example of such a top-level function. Okay, let's talk about function types. In Java, if we want a function that takes an integer and returns a string, we have this interface. If we need a function with 2 arguments, we have this interface. 3 arguments, well, you're out of luck. So unless you are using some kind of framework, you have to sit and write your interface on your own, right? So let's sit and write our interface. Then we use it like this and like this. I hope you agree that this is nothing but a concise and readable code. So what's the remedy for this situation? What could we do? Well, let's introduce function types. Here we say, we have a function with 3 arguments of type int that returns a string. We also have an alternative notation which infers both argument types and the return type from this lambda. And how can we use it? Well, we just say that we expect a function with 3 ints that returns a string. And then we call it just like any other function. If we need to pass it somewhere, then we can do it by name or by using a lambda, like this one, for example. And in Kotlin, if lambda is the last argument of a function call, we can take it out of this parenthesis. And if this lambda is the only argument of a function call, we can remove those parentheses altogether, just to make our code a bit more readable. Another great feature of Kotlin is extensions. So let's consider the following example. We need a simple way of converting all our strings into camel case. So the standard way in Java would be probably to create some string utils, put a static method in it, and then we could use it like this, or maybe like this with import static, right? The problem gets bigger when we actually want to do something with this string. For example, if we want to iterate over its lines. What's the problem with this code? Well, basically we have to read it from right to left instead of left to right, like our brains are used to, or even our auto-completion works. So how can we fix this? Or can we fix this? Let's try. Let's start with a similar setup. We have a function that takes a string and returns its modified version. In Kotlin, we can do something like this. We can say that this function will be an extension of a string type. What this gives us is that we no longer have to pass this string as an argument because we can access it by using this. And then we use our extension just as if it was a normal member function of the string type, after explicitly importing it. And I see your faces. How can this even work, yeah? The string is final. We shouldn't be able to do this. And the answer is quite brilliant, in my opinion, because under the hood, this will actually create a class and a static method in it, just like we would do it in Java. So only the syntax is more convenient for us. But under the hood, this works exactly the same. And if you look at Kotlin's standard library, you will see that actually most of it is made of such extensions. So for example, we have another extension of the string, which is called reader, which gives us a string reader. And there's another extension on the string reader type, which is called for each line, which iterates over the lines of the string using the provided lambda. And just take a moment and imagine the countless possibilities of this small feature. every time you had a framework or a library which was missing some important or handy method, now you can write it by your own within minutes. And it looks just as if it was inside of this framework or a library. And actually, on Android, we already have a whole library which is made entirely of extensions. It's called KTX, which stands for Kotlin extensions. And its sole purpose is to extend and enhance the existing Android types and give us some more pleasant APIs, like this one, where instead of writing a code like this, we can do it like this. And it does exactly the same thing. If we talk about extensions, we also have to mention collections, as in Kotlin they are actually related. So here we have a simple standard library function, list of, which gives us an immutable list. And then we perform some filter and for each, like functional iteration on this collection. But if you look at the source, in the source of those functions, you will see that they are not member functions of this list or a collection type. No, they are extensions of the iterable type. So you could ask, why? If Kotlin has its own collections, they could just define member functions on those collections, right? So the question is, does Kotlin have its own collections? If we look at the type, the return type of this function, first we will see that it's some Kotlin collections list. But if we dig deeper, we will see that on JVM, it actually covers our good old Java util list. So what's happening here actually? Well, Kotlin doesn't have its own collections. It only takes standard Java collections and extends them with those extension functions and extension properties. And this is actually a big one, because it's one of the reasons behind this seamless cooperation Kotlin with Java. Because if we have a Java method that returns some Java collection, and we call it from Kotlin, then Kotlin sees it as a normal Kotlin collection. And the other way around. If we have a Kotlin function that returns some kind of Kotlin collection, and we call it from Java, then Java sees it as a standard Java collection. And the best part is they are basically the same place in memory. So there's no need for any conversion. So this implicates that there's absolutely no runtime overhead. It basically works. Okay, and in this final example, I'd like to show you how a couple of those things can be used together to give us even more value. So we all know code like this, a kind of ceremony, certain steps that you have to do in the proper order, and you cannot forget about any step. Wouldn't it be great if we could, and this doesn't have to be a database, wouldn't it be great if we could hide all this complexity and make it reusable and simply make our code more concise and readable? Let's try. First, and the only important line of this code is actually this one. So let's try. First, let's make an extension of the SQLite database, which is the type of our DB. This extension will take another function as an argument, a function with no arguments that returns unit, which is basically Kotlin's way of saying void. So what should we put inside of our extension? Well, let's put exactly the same code as above. And somewhere between those lines, let's execute our block of code. So what should we put inside of this block, which will probably be a lambda, right? What should we put inside of this lambda? Well, let's put the only important line of the code above. And it's much better, but it's still not perfect, because we still have to qualify all of the calls inside of this lambda with this db and dot. It would be much better if this lambda was aware of this db instance, so we could access all of its members directly without this qualification. And in Kotlin, we actually can do this. If you look at this type, we can do something like this. This is called a lambda with receiver, but some people like to call it an extension lambda, because it basically works the same as extension functions. So first, we have to call it on some actual instance of SQLite database. And since we are already in the body of extension function, we can use this, which is an instance of SQLite database, right? So now, our lambda can access its receiver just like an extension function by using this. And because this, just like in Java, is optional, we don't have to write it at all. But now, someone could say that this code above is actually not equivalent to the code from the beginning of this example. Why? Because it has lambda in it. On the JVM, lambda is an object which has to be allocated, which takes time and resources, right? But in Kotlin, we also have a way of dealing with this. And it's actually nothing new in our developer world. It is called inline function. It's known from C++, for example. So how do inline functions work? Well, basically, each time the compiler sees a call to such a function, instead of putting a reference to this function, it simply copy and pastes the contents of this function into the call site. And in Kotlin, inline functions are even better, because also lambdas that are arguments of such functions, they are inlined in the first place. So let's see it step by step. First, the contents of our lambda will be copy and paste into its call site, so here. And then, all the contents of our function will be copy and paste in here. So what do we have now? Well, we have exactly the same code as at the beginning of this example. So what we've achieved actually, well, we've hidden all the complexity, we have made it reusable, and best of all, we have absolutely no runtime overhead. Because everything, especially inlining, happens during compile time. So it's basically a win-win situation for us. So I guess you can already call yourself a junior Kotlin developer. If you'd like to start to try Kotlin, it's actually easier than you think. If you visit their homepage, you will get all the documentation and also an online IDE, which I strongly encourage you to use. You can try Kotlin without installing anything. Also, IntelliJ IDEA already has a built-in support for Kotlin. So you can easily create new Kotlin projects, you can add Kotlin to your existing projects, you can even convert Java files to Kotlin files. I also I think that Kotlin Slack is a great place to ask questions. It's a very active and helpful community. And because Kotlin gets more and more popular, there's already a bunch of great online sources for getting new knowledge, like YouTube tutorials, Udemy courses, blog posts, and so on. So, thank you. That's it from me. I hope you enjoyed this talk. Thank you.